Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to this course of control system. This course is offered in Department of Technology in the program of Bachelor's of Science in Electrical and Electronics Engineering Technology. I will be your instructor for this course. My name is Engineer Jafar Ali. Starting with my qualification, I have done my MS in Electronics and Communication Engineering from SUT Peshawar. I have done MS in Electrical Engineering as well from UT Tesla, and before that I did my BS in Electrical Engineering from UT Peshawar. Currently I am affiliated with Department of Technology at Sarad University of Science and Information Technology Peshawar as a lecturer. Now coming towards the course description, uh, the course is entitled as Control System. The course title is the course credit hours will be 2-1. That means you will be studying 2 hours of theory and there will be one lab in a week. The prerequisite of this course is basically differential equations, signal and systems, and electronics. You see, this course is basically the core course of one of the core courses of electrical and electronics engineering technology, and it is the basically the final course that you will be studying to that much of enhanced level. So that is why the prerequisite of this course varies a lot. Um, the textbook that we will be following will be Automatic Control System by Benjamin C. Kao, and you will also take help from the other book that is by Joseph J. DiStefano. That the book title is Feedback and Control System. You can take another books also into account. The books can be Norman Nice, Ugata, or any other book, but we will recommend you these books which I've already told you. So coming towards the assessment and grading policy for this course, I have divided this course into several activities. You will be taking quizzes, you will be submitting assignments online, and in the class I will tell you that how you can submit your assignments online. There will be 4 quizzes as well, but the best 3 will be counted. The fourth one, which will be your worst one, will be neglected. There will be a midterm of 20% marks, there will be a final term of 40% marks, and there will be a lab and viva that will weigh about 25% marks. There will also be a research project in which you will present a project or any topic, a decent research topic, and that will be weighing about 5% of marks. So starting from today's activity, today the topics that we will be covering will be introduction of control system, a brief history of control system, introduction of some of important advanced control system, important components that are involved in the making of a control system, and about the control system design process, that how you can design a good control system. Designing is not your part, but if you want to apply implement any design, you need to have some background of a good design. That is why we will teaching you how a good design can be made up of, and what are the major key components that you will have to look over before implementation of a good design. In the last, we will talk about different types of control system that you will see in your practical life and practical fields. Starting with the introduction, control system is basically comprised of 2 words. One is system and another is control. So I have literally chopped down these 2 words so that you can understand it in a good manner. What is system? You know that system is basically interconnection of devices or elements, and they are connected in such a way that they can give you a desired output or desired result. So the purpose of a system can be some to follow some particular task, to follow particular instruction. That is a system, and the system has the components of inputs as well as output. A system can be a system with an input and output. Control is basically types of actions that we talk about in control system, any practical field. The first one is switching. If you talk about switching, means to turn on or to turn off, that is control. Or you can say that control is the manipulation or the fluctuation or amplification, degradation of some gain or some value. So if I tell you to increase the speed of a fan, you do not need to switch on and off the fan. You need to increase the speed. So for that, you will need to increase the gain of the system. So you see, there are two things in control. One is basically switching, and the second one is basically amplification or the decrease in gain. That is termed as control in electrical terminology. Now, combining these two terms, what does a control system mean? A control system is an interconnection of components forming a system configuration that will provide you a desired response, a desired outcome, depending upon your choice, depending upon your desired function. And what is the process? The process is basically the whole scenario, the whole device, plant, system that you are using to control the output. You give an input, you control the and every other scenario, the device, the system, the environment, the factors that are involved in this process. So you control the whole system basically. That is basically termed as a process. A process is a combination of all these activities that are going on to control a system. Now this is basically a brief history, and I have only shown some of the landmarks that were achieved in the history of control engineering. It was all started at 18th century when James Watts, the inventor of a centrifugal governor, he controlled basically the speed of a steam engine. From there it all started, and after that in 1920 Minkowski worked on several automatic control for steering ships. At that time, the ships were really a part of a huge part of a transportation system, because at that time cars were not that much of performing practically. Ships were really into the market at that time. And in 1930, a major landmark occurred when Nyquist developed a standard, or you can say a layout, or a criteria that measured the stability of a system. So that was a landmark, and we will be studying that how Nyquist controlled or investigated the stability of a control system. So we will be studying that in course as well. So in 1950, another method to analyze a system, to check the stability of a system, another method was developed, and this is known as the root locus method, and we will study that too in our course. In the late 60s, another several other methods like state space and optimal control, adaptive control were also developed. And in the 1980s, a different learning control and optimization of different control systems were investigated and developed as well. So these are the some of the break marks that were achieved in the history of a control engineering. Now what is control system? Basically, you see in the diagram showing over here, there is a water level flow regulator, and this was all mechanical at that time. You see there is a bubble of air that is flowing over the water, and this basically shows the level of the water in a any beaker or any bar. In human system, you also see a parallel control system. In human body, there is a pancreas, underline, eye, hand, temperature. These, you see, our body is also a kind of control system. We take input like food, and we give output like actions, like I am talking to you, this is my output. So my body is also a kind of control system, and different factors that are involved in this control system are pancreas and all of these are the main subsystems that are involved to make over the complete system of our body. And overall, this is known as a process. I take some input, I work on it, and I give it to the output. So it is also known as a control system. Another example of a control system is given on the screen over here. You can see that there is a man who is controlling the valve to fill up a tub, or you can say a beaker or a drum of water, and there is some input that is flowing inside the tub, and the man is controlling the valve to let the output, to control basically the output depending upon the eyes. You see the man is keep looking at the man is staring at the bar, so that he can judge whether to turn the valve, open the valve, or whether to close the valve. And The man is controlling basically the output, and it is also taking input from his eyes. Similarly, there is another example of a boiler of a thermal plant. You see that there are many inputs and many outputs over here, and there are several factors that are involved, like oxygen measurement, temperature measurement, pressure measurement, speed governor, generator, turbine, shaft, boiler, and several valve. These are taking several inputs. Three are the inputs, and there is one of the output, and all the other you see the parts are working in specified manner that is specified by the designer. Similarly, you see the diagram of a electric furnace over here. You take some input, you take give an output, and the input is provided by a computer to through an interface to an amplifier and a relay, whether to operate the heater that is uh, uh, adjusted or deployed in the electric furnace. The best example then from that you can understand the control system is of transportation. There is a car and a driver. Now the purpose of a good driver and a good drive can be that the speed of a car does not vary too much, and there is no obstacle in front of that car. The direction can be the direction is the direction should be right. It should not move away from the direction it was targeted to achieve. So the main objective of the transportation is to control the direction and speed of the car. Now the outputs are basically the actual direction and speed. And what are the control inputs? And the control inputs include road markings, signs, speed breaker, any obstacle in the road. It also counts in disturbance, that is the road surface, grade, wheels, etc., and the friction between tires and the wheels, tires and the road, and also some obstacle if someone comes in front of the car. So this is also a disturbance which is resisting you to achieve your desired speed and desired direction. You turn the wheel to dodge the obstacle. That is why this is all a part of a disturbance. And possible subsystems include the car, the wheel system, the axle system, the engine, the tires. These all are the subsystem of a complete process. So you see this is that kindly look at the diagram over here. The blue line is showing the actual travel and direction of travel, while the black line is the desired direction and of travel. So you want to follow the desired direction of travel, and for that you need the driver, the steering mechanism, and some feedback that will measure that you are going in the right direction or not. If you actual course of travel is not the desired course of travel, so here in this part here in this part will be using to generate some error, and this error will be injected or indulged in the driver mind or driver personality, and the driver will control the steering and brakes and other components. You could control any of these mechanism to achieve to control that automobile so that it could follow the desired course of travel. Now, what are the advantages and the benefits of a good control system? A control system could provide you an improved control, enhancement in product quality. The minimization of waste can be done using a control system. You want to waste a least amount, the least amount of the resources, so that is achieved by a control system. Environment protection, you can monitor the environment, you can see that how much you can have reduced the environment pollution or air pollution or anything like that. Nowadays you see the new Japanese car that they are manufacturing, the engine of that car makes zero noise. That is why they are eco-friendly, they are called eco-friendly, and they have achieved all of this due to the control system. You can achieve greater throughput for a given installed capacity. For example, earlier in the old days, earlier to achieve a specified output, there was In the earlier days, you remember that it was discussed about per acre cost, per acre yield. You have an acre of land and you want to produce some product or yield on it. So let's say you produce a ton of it. Nowadays, using the urea or anything like that, you can produce more than a ton. You can produce 4 ton, 5 ton, or even 10 ton, just because they have developed a process that is achieved by the control system, and they have increased their yield. Now, if the increased they have increased their yield, the prices of the yield due to the demand and supply will be gone less, so that a layman can buy it for themselves. Similarly, you can achieve higher safety margins using a control system, as we have discussed from in the last slide of transportation example. Now, what is a successful control system? A successful control system in engineering depend of some of the issues that are the process that is involved in the plant, objectives, that what are your key objectives that you are trying to achieve, what are the sensors involved, and how the sensors are working. Are they working efficiently? Are they working? Are they using a lot of power, and the lot of power is going to waste? If the sensors are the sensing range of the sensors is good, if the sensing power of the value that the sensors measure is accurate, is precise, so that is where it comes from the side of sensors. Now, what are actuators? Actuators are basically the thing that reacts to the input of sensors. When a sensor senses something, it gives the output to the value that it has senses to some machine, and that machine, if the machine reacts upon it, for example, if a machine senses there is a fire in a building and it reacts the value, it gives the value to the let's say relay or a power sprinkle. Now that power sprinkle has become actuator, because he has to act accordingly to the from the value given from the sensor. Another thing is computing. This here comes the processor. Basically, if you have a good computer or a good processor that is looking over all the scenario, so you are in good hands of control system. And you have to take disturbances and uncertainty into account. Let's say if you have developed a system but you did not took a disturbance or noise into account, so if in the practical scenarios, if some noise comes in the system will not have be able to respond to that noise, and it will produce some garbage value. So for that, you need to have some good accountability of noise, disturbance, or any uncertainty. Now, coming towards one by one of this whole portions or whole subsystem of a good control system, the plant is basically the layout of a process where you actually implement the your desired function, your desired output, your desired control system. So the physical layout is basically known as plant in terms of control engineering. A control engineer needs to be familiar with the physics of the process under study. If you know about the land, if you know about the layout, you can actually perform better. If you do not know about the layout, if you don't know about where you are heading to, which from the road, if you do not know your destination, so you do not know about the path that you are following, you could be in trouble. So that is why the physical layout is really important while talking about control system. What are objectives? Before designing sensors, actuators, or control architecture, it is very important to know about the goal. That is, to formulate the control objectives, you must know about the main target of the main objectives that you are going to achieve from this control system. So, if, for example, if you say that I want the reduction in energy consumption, so your main target is, so there are two kinds of objectives. One is known as primary objective, and other one is known as secondary objective. You cannot the primary objective of any of the control system is basically the most important objective that you want to achieve. Let's say if I want to increase my manufacturing manufacturing quantity. Let's say I have a factory, I run a factory, and my factory produces, let's 1,000 pieces of anything in a day, and I want to increase that output. by 2000, the number of 2000, I want 3000 per day. So this is my primary objectives. Other than that, if I say that also increase, if you are increasing the amount, also increase or decrease the time. So the secondary objective will be the reduction in time. The first objective was to increase the product quantity, and the second objective become my reduction in time. So the first one is termed as primary objective. You have to achieve some of, now there are two concepts over here, and I will tell you that I believe in the second one. The first is that you have to achieve both of the objectives, primary and secondary. If there are one primary and two secondary, you have to achieve all the three. If there is one, and the other concept is that if you have one of primary and two secondaries, so the first one, that the primary is have to be achievable, you have to achieve the first one, and the other two are not necessary. So it depends totally on the client that what design he want. If he want all of the three to be taken into account, so you have to target it, you have to target all of these. But if he want the first one as very important, and he want, but he do not want to force you to achieve the second two targets, so it could be your secondary objectives. But the primary objective must be achieved in any of the cases. Now, what are the variables involved? You also want to, before after designing the objectives, you have to take the variables into account, that what variables that I will be experiencing with. If you want a good fire alarm system, so the sensors must be in good quality, in good sensing range, in good measurement value. The less error of the sensor means the greater quality of a fire system. So these all comes in the variables. So you have to take many variables into account while you are designing a good control system. And you also want to achieve some performance level, so you mark the level. Let's say I let's take the previous example. I told you about that, my I want to increase my manufacturing capacity to 3000 pieces of anything per day. So what will be the performance level? Let's say one of the thousand piece my thousand pieces uh, go to uh, die in 2 days. Now if or 2 weeks, if I am making 3000 pieces a day, what will be the quality of that product? So if I say the performance level can be uh, degraded or uh, leveled down to 80%, means if not in 2 weeks, let's say in 10 days, so it is not that bad as well. You can go with that solution as well. But any industry, the manufacturer, the industrialists, they want the best quality, the best results, and in that too in low cost. They No one will tell you that you have to increase the production rate at 3000 or 4000, but it's okay to, if you want to compromise on the quality. No one will tell you that. Everyone will tell you that if you want to increase the manufacturing rate, as well as they want to increase the quality, but there will be some cost that you will be paying if you want to increase something. It is not every lunch is free, as you know that. You have to take some kind of a trade off. You have to do some kind of trade off while increasing one factor, and you have to manipulate other factors as well while designing a system. Now, what are sensors? Sensors are basically the eyes of a control system. If the sensors are working properly, they will tell you about the real output that the system is giving. If the system, if the sensors are not performing well, so you cannot measure the actual output, and you will be assuming that the sensors are giving me the right value, and the output is okay. But the output will not be okay, because your sensors are wrong. Your sensors are giving you the wrong readings, the sensors are faulted. So you need to have good sensors. If you have good sensors, you can measure the actual readings as compared to the assumption. There is a famous Chinese quote actually: if you can measure it, you can control it. So a good measurement means a good sensor, and a good sensor will cost you more as compared to a bad one. Actuators are basically as of As I have already told you that actuators are the machines or the part of the machine that reacts with the readings of the sensors. So this is the basically known as actuators. And in the good control systems, this is the layout, or this is the final, in short, that sensors provide the eyes and actuators are the muscle, but the control side provides the fineness. You will, if you have good sensors and good actuators, so you will go, you are, it means that you are going to the fineness of the control side. Best sensors provide better vision, best actuator provide more muscle, and best controls mean the computing, the processing speed, the other factors involved in it. So the output will be really great. Now, what are disturbance and uncertainty? All the other noises, external disturbance that disturbs your system, they are laid down in the term of disturbance and uncertainty. Uncertainty. You do not want your system to be to perform really bad when it comes to disturbances, because in heavy machinery, in factories there are heavy machineries and they produce a lot of noise. So you do not want your system to give you garbage value or random value when it comes to noise or any other disturbance. So you have to take that into also you have to take disturbance into account before designing uh, a control system. Your control system must be good enough to avoid that disturbances, or your sensor must be good enough to take proper readings in the presence of noise, in the presence of external disturbance. If the sensors are working well in the without the noise, so it is not a good system. But if your sensors are working well and it is providing you the real readings in the presence of noise, now these sensors and or these actuators are basically a good one as compared to the previous ones. Now, now coming towards a control system design process, that what are the key factors that are involved in the complete process of a good design of a control system. First of all, you have to establish control goals, that what targets you want to achieve. Then you have to identify some variables that you want to control in that process. Now after that, you want to specify that variables, that what are the specifications that will be noted down and that will be taken care of during the whole process. Because you want to control the system, you have to control the small variables. After that, you have to establish the configuration, and all you have to basically establish the interface, or you can say the connection or the links between all the variables, so that if one of them is not working properly, it will destroy whole of the control system, it will affect all of the whole control system. So that is why you have to establish a system configuration. And you will also have to identify the actuator, that what will the output of the sensor and the output of sensor will be given to which actuator, and the actuator will perform in how in which manner. That is in objective number 5. You see that obtain a model of the whole process, the actuator and the sensor. From this you will have a detailed idea till knowing about all of the details that you will be doing in the process, and how the actuators and sensors will be communicating with each other, and all of the details will be given after you have achieved level 5. The level 6 is basically you have to design a controller and select the key parameters to be adjusted. You will see that how control system is responding, and with that the output of that system, you will have to design a controller that will manipulate some variables in your according to your choice. And by what I means from the manipulation, you have to change some more or modify some parameters. You have to adjust some parameters so that the output of the system will be equal to the desired output of your choice. And at the last, you have to optimize the parameters and analyze the performance. Now what do I mean by optimize? Building a system is not a difficult task, but after you have developed a system, you have taken care, you have achieving your desired output. Now the purpose of the main control system is to minimize the cost, minimize the effort, so that this system could be good enough. So to decrease the cost, to increase the speed, to minimize the noise effect, you have to further optimize that system. You have to make the system more neat, more understandable. You have to merge some blocks, you have to open some blocks, you have to simplify some equations, and that is done in level 7, that is optimization of parameters. Now coming towards the last topic of today's class, the classification of control system. So there are two classes of control system. One is known as open loop control system, and the second one is known as closed loop control system. The name shows about the definition of these systems. Open loop system is that system in which you give input to a system, and the system performs and it gives some output, and you do not care about the output. The second class, that is closed loop control feedback system, in which you have to take the output and give it to the input, so that the input get to know that this output is my desired value or not. If it is not desired value, then this comparison has been done. uh, then this comparison needs to be done, and the result of that should be given into a controller, so that the controller should manipulate some of the variables and give it to the process, and that the circle goes on until and unless the desired output or the desired result is achieved. So closed loop control system has a much better results as compared to the open loop control system. I have given you the example over here in open loop system and control loop system. This is an example of a room temperature control system. You see that a thermostat will be needed to measure the temperature. If it is not your desired temperature of a room, so it will keep giving it back to the controller. You see that the output of a room is given to the thermostat. The thermostat will be used as a sensor. It will sense the measured value of our actual room temperature, and it will give it to the controller, and the controller will further increase or decrease the gas solenoid valve or gas burner, etc., to control the room temperature. Now you see here is the comparison between open loop and closed loop control system. You see that the open loop control system is very easy to make. It is less expensive because you do not need to have feedback or feedback sensors. But there is a stability problem. The system can become unstable, and you will not have any idea that the system is not performing well. So this is not accurate and not reliable system in open loop system. But in a closed loop system, there is constant feedback, and you will have the best knowledge about the output. But the results are the results of closed loop system are more accurate, but the cost we are paying will be about money, and that money will be invested to buy a good sensors or feedback, so that the value of the output will be a real value, so that you know about the real value of the output, and you can manipulate or control different parameters or variables through the controller. And closed loop system also are complex in nature, because you have to make several things into account before giving to the controller. These are the some further classifications of control system: continuous time feedback control system, and discrete data feedback control system. In both of these cases are in the difference is that the signals basically that are involved in the, if the signals are continuous, so we will use in the continuous time feedback control system, and the signals are, if the signals are discrete, it is occurring after some instant of time, that is using a sampler. You have to sample different data and make it a discrete signal. If the signal is discrete, so the system should be a discrete time feedback control system. Further classification includes, these are all small classifications, but they are really important. If you want to work on a system, you have to know about that what kind of system you are working with. A linear control system is such a system in which if you change an input, the output is changed accordingly. If I increase a system by a factor of 2, so the output of the system will also have to be increased by 2. If you are working on such kind of system, so that system is basically known as linear control system. But in most of the cases, you see that this is not the practical scenario, you increase the system input by 2, but the output is not increased by 2, and it is increased by, let's say, 1.5. So such kind of system is termed as non-linear system, because it do not obey the superposition theorem or superposition principle, which means that if you increase the input, the output should be increased accordingly. So most of the systems nowadays are non-linear systems, but we are trying, we want our system to be linear, so that we have a clear idea that if I have doubled my input, the output should be doubled. Now coming towards different definitions and terminologies that are involved in a control system, you have to look at some controlled variables, that what variables you want to control, and some are manipulated variables. Manipulated variables are those variables which you are going to control, and using that manipulated variable, you are basically controlling the controlled variable. Some of the variables are already controlled, some you want to control, so you have to you have to use manipulated variables. You have to change some variables to control that actual variables that you want to control actually. So this is small definitions of plant system disturbance and what is a feedback control. We will discuss in detail in the class, inshallah. But if you have any confusion, and if you have any want to ask any question, you are more than welcome to ask, and we will discuss in the class, inshallah, on Zoom tomorrow, or in the coming classes. You can ask me any question over there, and you can also reach me at my email if you want to, if you have any confusion. That's all for today. See you in the coming class. Thank you. Allah Hafiz.